In continuation to the previous lecture, today we will start laboratory chemicals. Several laboratory chemicals are controversial from the perspective of green chemistry. Ethidium bromide, xylene, mercury, and formaldehyde have been identified as worst offenders which have alternatives. Solvents in particular make a large contribution to the environmental impact of chemical manufacturing, and there is a growing focus on introducing greener solvent into the earliest stage of development of these processes. Green chemistry in day-to-day life. Green dry cleaning of clothes. Perchloroethylene is commonly being used as a solvent for dry cleaning. It is now known that PERC contaminates groundwater and is a suspected carcinogen. A technology known as Michel technology, developed by Joseph D. Simon, Timothy Romack, and James McLean, made use of liquid carbon dioxide and surfactant for dry cleaning cloths, thereby replacing PERC. Dry cleaning machines have now been developed using this technique. Michel technology has also evolved a metal cleaning system that uses carbon dioxide and a surfactant, thereby eliminating the need of halogenated solvents. Second is versatile bleaching agent. It is common knowledge that paper is manufactured from wood, which contains about 70% polysaccharide and about 30% lignin. For good quality paper, the lignin must be completely removed. Initially, lignin is removed by placing small chipped pieces wood into a bath of sodium hydroxide and sodium sulfite. By this process, about 80 to 90% of lignin is decomposed. The remaining lignin was so far removed through reaction with chlorine gas. The use of chlorine removes all the lignin to give good quality white paper but causes environmental problems. Chlorine can react with aromatic rings of the lignin to produce dioxins such as 2,3,4 tetrachlorodioxin and chlorinated furans. These compounds are potential carcinogens and cause other health problems. These halogenated products find their way into the food chain and finally into products pork, beef, and fish. In view of this, use of chlorine has been discouraged. Subsequently, chlorine dioxide was used. Other bleaching agents like hydrogen peroxide, ozone, and oxygen also did not give the desired results. A versatile agent has been developed by Terence Collins. It involves the use of H2O2 as a bleaching agent in the presence of some activators known as TAML activators 10 that as catalyst which promote the conversion of H2O2 into hydroxyl radicals that are involved in oxidation. TAML is tetraamido macrocyclic ligand. The catalytic of tetraamido macrocyclic ligand activators allow H2O2 hydrogen peroxide to break down more lignin in a shorter time and at much lower temperature. These bleaching agents find use in laundry and result in lesser use of water. Third is green solution to turn turbid water clear. Tamarind seed kernel powder discarded as agriculture waste is an effective agent to make municipal and industrial wastewater clear. The present practice is to use aluminium salt to treat such water. It has been found that alum increases toxic ions in treated water and could cause disease like Alzheimer's. On the other hand, carnel powder is not toxic and is degradable and cost effective. For the study, four flocculants namely tamarind seed kernel powder, mix of the powder and starch and alum were employed. Flocculants with slurries were prepared by mixing measured amount of clay and water. The result showed aggregation of the powder and suspended particles were more porous and allowed water to ooze out and become compact more easily and formed larger volume of clear water. Starch flocks, on the other hand, were found to be lightweight and less porous and therefore didn't allow water to pass through it easily. The study establishes the powder's potential as an economic flocculant with performance close more established flocculants such as potash alum. Now the conclusion of green chemistry. Green chemistry is new philosophical approach that through application and extension of the principles of green chemistry can contribute to sustainable development. Presently, it is easy to find in the literature many interesting examples of the use of green chemistry rules. Great efforts are still undertaken to design an ideal process that starts from non-polluting materials. It is clear that the challenge for the future chemical industry is based on safer products and processes designed by utilizing new ideas in fundamental research. Furthermore, the success of green chemistry depends on the training and education of a new generation of chemists. Students at all levels have to be introduced to the philosophy and practice of green chemistry.